think I just unmuted. So welcome everybody to our first TWed of the fall 2022 semester and our first in-person TWed in a very long time. We're very happy to have Jamie McCusker here to take us through Whyis 2.0. Probably the Whyis 1.0 was probably one of our last TWeds. So I'm going to switch off our screen share and.
Okay. Sure. So hi, yeah. We're going to be talking about Whyis 2.0 today, and yes, I'm going to start sharing my screen.
Okay. But little logistical thing. Sorry, I'm out of practice.
Yeah, sure.
So just as a couple logistical notes, I should mention number one, this is being recorded for later presentation in the web.
Oh, wait, sorry.
They can probably see.
I don't think I'm. I wasn't muted. Oh, sorry.
That's okay. So it's being recorded, so feel free to ask questions. Well, if our discussions get too long, I may expedite the presentation. But just keep in mind that we are being recorded forever and ever, amen, on the web. And you can find a schedule for upcoming TWEDs and also our Pirates, the RPI, our users group meetings on tw.rpi.edu/TWED. And I think that's
cool. Yeah.
just maybe better.
Okay, so yeah, Whyis 2.0 is basically the next version of Whyis. One of the nice things about it is that it is we put a lot of effort into making sure that it is a fully a very simple system to use and install. Whyis is available as a Python package. It's available to run basically directly on laptops in a very straightforward embedded mode. It has a lot of scripts and support around deploying to both Docker containers and to production servers. This is virtual machines. So that's all set up in a way that where kind of we've solved a lot of those problems for you, a lot of scripts around that. So hopefully this actually will help you. This will help you kind of get started with Whyis. The other thing we've done is we made sure that the out-of-box experience is quite a bit better than the old one. You can actually use Whyis for basic knowledge graph applications without writing any software. This is a big deal for us because that's not something we generally do in our field. So hopefully this will help that along. The nice thing about Whyis is that because of the way it's structured, even though you might start off with a no-code project where you're not actually writing any software, you may decide later on that you need something in place that will do one of those things. It will, maybe you need a custom view or a custom agent, and I'll talk about what those are in a little while. You can transition from just doing just loading data and exploring it all the way over to writing a custom knowledge graph without any disruptions. You can just start tinkering with it, and I'll hopefully I'll have time to kind of show off where you would go about making those changes and how you would go about doing it. So for those of you who are, there we go. Those of you who are familiar with the old Whyis architecture, we've made a number of changes to the approach that we've had in a lot of the technologies that we have. The original version of Whyis was based on Blazecraft, which has been a wonderful tool, but it's rather monolithic and has been, basically the entire team's been absorbed by Amazon, and so the support isn't what it used to be. And so we've decided to switch over to using Fuseki from the Apache Jena project, which is very actively developed and is modular, and we're actually able to write an extension to Fuseki as part of the transition over to of Whyis to TWed. And so that's kind of part of the appeal now of Whyis, is that you can actually tinker with Fuseki itself as part of one of your Whyis projects. You don't need and basically develop and add modules to Fuseki to add new things, whether it's geospatial or if you want to write a authentication or authorization module or do any of those other sorts of things, that's absolutely there.
Good DNA.
It's got good DNA, yeah. And Fuseki is, yes, a very venerable project that goes back since basically before I've been involved with the Semantic web. So another major change is the use of, we were using a JavaScript framework called Angularjs, which is back in the day was actually a very convenient way to kind of do model view controllers in JavaScript, and we had a lot of success with that. But Angular has been showing its age for quite a while, and we haven't actually moved along to Angular 2.0, which is radically different from what we were using with Angular 1.0. And so we kind of did a reevaluation of what we were doing and realized that Vue.js is actually more in line with the sort of component system that we really wanted to use and to make, and it's much lighter weight. And we're able to, we're in the process of switching over a lot of the front-end components to Vue.js from Angular. There's still a lot of technology that's using Angular, but going forward, as we make new user interfaces in Whyis, we will be using Vue. And we will be gradually transitioning those over to Vue from Angular. And actually, one of those first components that we've been trying to switch over is the original faceted browser from Whyis, which was useful but kind of unreliable in some ways. We've basically built out this visualization framework, and actually still have to come up with a good name for it because it's not going to be BobViz. That's a nod to Prov. When back in the very beginning of Prov, we called Prov entity just Bob because we didn't want to bias ourselves towards any one name or another. So I've been calling it BobViz just because there's not a good name for it yet. But what it is basically a framework for plugging in search capability. So basically formulating and executing a Sparkle query with visualization or exploration capabilities, being able to display the results of that query somehow. And the very basic version, and I'll show you a very basic version of it, which is you write a Sparkle query and then you write a Vega specification for a visualization, and you can get this lovely graph. That is far more appealing to me than it should be. Yeah, I might do that, and yes, that's extremely tempting because I love a good pun. Okay, so we've also integrated Data Voyager in with this, so that instead of just writing a Vue visualization directly, you can use a user interface to compose one. And so hopefully I'll be able to show that. I've got some demo data that I might be able to probably be able to use for this. And then the other thing is that, so the BobViz system, actually, the idea is that a lot of these pieces that you see with when you're doing these sorts of tasks, whether it's looking at a gallery of instances that either you've just got a Sparkle query and you want to see those kind of summaries of those instances, while you use maybe a faceted browser or just a straight query, and a gallery component to do that, or an album component. When you're just showing a visualization, you just kind of have the metadata. You don't really offer editing of the data. You just run the query. And then when you're doing when you're editing a visualization, you would then show an editor for the Sparkle query or whatever else you're using. So that's the idea, is that this will eventually, it's not quite there yet, become a way for people to compose novel user interactions within Whyis without using a lot of code, right? You'll be reusing you can mix and match a lot of these components to do interesting things, and hopefully when it comes time to actually write a knowledge graph, you can just plug them together using, it would be probably about 5 lines of HTML to do that. Yeah. Yeah.
A way so that non-ontologists or in the field, they can still work on the same thing without knowing the techniques of it, get the results.
Right, yeah. So that's the idea, is that people who know how to people who can write tools for that can write Sparkle queries for them. So like a faceted browser or something else. Those sorts of people who are really good with Sparkle can write those sorts of tools. And then other people who are building knowledge graphs but maybe aren't like Sparkle experts can still put together sophisticated knowledge exploration tools using those pre-built components. So that last page was more vision than anything else. Yeah, this is so one of the cool things, yeah. One of the cool things though about this graphic is that I didn't have to change it at all. It still applies. This is Whyis 2.0 as well. And over the course of, I guess it's been 5 years, this architecture has held up and hasn't had to change at all. And so, we still have basically knowledge curation through agents that can either read in, actually we've filled in this gap. We didn't have semantic data dictionaries way back in the day. That was a visionary thing. That's now done. Semantic ETL is being done through Settler. We have some NLP pieces in place. We haven't really done much machine learning yet, but we really want to. The linked open data mapping has been like a workhorse of Whyis over the years. Whether it's mapping in OBO ontologies class by class, whether it's been pulling in ORCID and DOI identifiers and pulling in metadata from there, or using DBpedia or anything else, it just keeps going, and we keep finding new interesting things to do with it, including on-demand loading of files from remote sources so that we can actually do semantic ETL of these files that are published somewhere, pull them through, process them, and then publish the data right to the graph. So it's actually been really cool on that end. The knowledge interaction piece is still works more or less the same way that it always has. It uses views to every entity in the graph has at least one view, and there are lots of views available for many of these things. Some of them are web-based, so HTML pages. Some of them are data-oriented, and so they're usually JSON-based APIs that are based on these views. And all these things are actually really just, that they continue to work, and a lot of these pieces have been more about changing what's the content of those views than about actually changing the underlying architecture. And so, some stuff that we're looking at for views is like, well, what do you do when you want to post something to an entity? What would that mean? So questions like that are more like, how do we expand on what we already have rather than how do we change what's already there? So that's, again, held up really well.
At post, you meant
Yeah, exactly, like HTTP post. What does it mean to, if you want to post a revision of a fragment of a CSV file to that CSV, you could potentially do that. You just need to write that view to do the processing. And then similarly with knowledge inference, the inference agents are the same that they've always been, and really are still working on a nanopublication and by nanopublication basis. The use of nanopublications and the use of prov-oriented nanopublications to trace changes in the graph, all of that's still the same. And so a lot of it's been like, how do we improve this performance, or how do we deal with this corner case that we didn't hit before? But all of these underlying concepts have held up for 5 years. And so the main thing, again, this is another dusty slide, but I actually did dust it off. Basically, so I took off the specifics about this JavaScript stuff, because we're kind of in transition right now, and I wanted to have it be honest. But again, there are views, there's linked data mapping, there's, I used to call them knowledge expansion agents, inference agents that I mentioned. And one of the main differences is that we've changed over to Fuseki from Blazegraph. And so that's been really, that's pretty much it, right? The rest of this still, again, holds up. And we haven't had to add any backdoors. We haven't had to add any new features in terms of the architecture design for quite a long time. And, some of it's stubbornness on my part, but a lot of it's just been that what we've been able to get those things to work in a lot of different situations in 5 or 6 different projects. So that's been really, really valuable. I think that we were able to do that. Okay, so that's all I.
There's an architectural question.
Yeah.
And the first is just kind of a comment.
Mm-hmm.
I may have mentioned this before. There's a certain, some of this is kind of analogous to this digital repository. To say,
Yeah. Yeah.
One of the novel things. So that was kind of that their architecture is sort of based on not this version. This seminar. So
Mhm.
we had a visual object. Essentially through different kinds of calls of the idea.
Right,
To
yeah.
disseminate different manifestations of it
Mhm.
or information about it.
Yeah, yeah.
And so, and there was also, to some extent, there was the converse was, this is what, and with the first thing, you could conceivably modify. Yeah.
Right, yeah, yeah.
But I'm wondering where that sort of direct interaction, not a browser based on a sort of a API, kind of rich API interaction. From a dissemination standpoint, does that kind of fall under custom views? Where would you put API rather than a browser?
Yeah, so that's these custom views. And so about at least half of the the views that are used in Whyis are actually data views. So I distinguish between web views and data views. Web views serve HTML. Data views serve JSON or XML or some other data structure. And the difference there is more a matter of what you write than anything else. Rather than writing, template name.html, you write template name.json. And it serves up JSON instead.
So it's a post. Is that kind of
It's a special
limited-
case that-
limited view,
That's
primitive?
that's a special case that I'm still trying to consider. And it's something that, so on the one hand, this has been sitting around for 5 years. On the other hand, I've been thinking about what a post would mean in this architecture for about 3 of those years. So that's not, that's part of this process is, trying to make sure that I'm thinking through what each of these things means. As it
About the
goes.
signature.
Right, yeah, yeah. And so, the post is usually a modification or creation process. There's also put and patch and so forth and delete. Right now, if you post a file to a URI in Whyis, it will upload that file and actually serve it back to you whenever you do a get on it. So it basically means that URI is representing the file you posted. And you can post a new file each time. And you can provide some basic type information as part of the post parameters. And it's basically an entity in the graph. So you can link to it, you can add other facts about it, you can link to other stuff. So we do have some semantics around post and delete for file-oriented entities or resources. And we also have that available for the nano publications themselves. Hmm? Yeah. Yeah, I can. So if you've and actually one of the fun things is that I have perl.org/whyis/local/ redirects to localhost 5000. And that's also the default URI space for Whyis when you install it from scratch.
I promise to keep things moving.
Yeah, I know, yeah, good job. Okay, so let's see here. I am going to, oh, right. So one thing I want to show off to show my, to show what we've been up to is we've also put in a lot of effort into documentation. That we have, so a lot of this stuff actually had been available previously as part of 2.0. I've translated over as much as I could to 2.0, added some new things around installing Whyis and reference documentation for the command line interface and the web API. And yeah, so if you actually do a get on something that's like a direct link into whatever the LOD prefix is. I'll talk about that more later though. Anyway, so actually, let me make this a little bit bigger. Okay, so Whyis, like I said, is a Python package. So one of the first things you want to make sure is that you have Python 3.9 installed, or 3.7 or later. I've been doing most of my work with 3.9. That seems to be very solid and stable and generally available, so go for it. The other thing you need is Java. Where is it? Yeah, so you need a Java 13 or later for Fuseki. So you need to make sure that's installed. Between those two, that should be about it. I think that covers I think everything else is covered as part of the installation process. So Jenna, Fuseki uses Jenna kind of throughout, so it's built on Jenna. Yeah. Let's see. Let's pip is usually comes with Python, at least these days. So what I'm going to do is this command in Python called ven. It's a virtual environment. Most people who I've dealt with before, or who I've talked to you about this process before, I've been pushing really hard. So people use virtual environments for Python because really it's kind of a mess if you don't. And so I really, 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 really recommend you do this. Except in Docker, you're not supposed to do it at all. Although no, actually the Docker image also uses virtual env. Whyis demo. Hmm? Well, so Docker itself is just it's an OS environment, right? Basically a virtualized OS environment, containerized, not always virtual. What happens inside of there is that you still need to do the same stuff to run Python that you would otherwise.
Right.
You can install stuff into the system Python packages just fine, but just as a matter of kind of knowing where stuff is, I prefer to build the virtual env already. And part of it's that then it's just a little bit more predictable between everything. So, okay, so I create a venv, then you have to activate it. Whyis demo bin activate. And no, I have not tested this with Anaconda. I've grown disillusioned with Anaconda like 10 years ago. Really don't like it. If you want to use it, go for it, but supposedly all the pip stuff also works you can use a pip package in Conda as well, because the Python packages have become much more comprehensive than they used to be. And so a lot of the stuff that was hard to install using pip now actually is pretty easy, and you're about to see that. Yeah, sure. If you have a GPU and you install a package that uses it and write an agent that uses it, it'll use it. There's nothing in Whyis that requires it. There's nothing in Whyis that prevents you from using it either. Yes, although I think, well, so depending, it's a matter of style, right? And so Anaconda is not really, it's really good for like data science type stuff, but it's not really, I wouldn't use it for setting up a server deployment or something like that. I don't know how, I've seen it get temperamental with a lot of that stuff, and it's much more opaque in terms of what it's doing. Like I just made a directory called Whyis demo venv. I know where it is. If I want to get rid of it, I just delete that directory. Pip install Whyis. This is the moment of truth. Actually, why did it do that? Oh, sorry. That's actually an old one. I just made I already had this in place. Here, I'll just do that. Whyis venv. Source. Whyis env inactivate. So I want to make sure that I'm not cheating for this. So I'm doing an empty one. Okay, so it is caching everything because I already tested this. But that's good. You don't have to wait for downloads. Mm-hmm. It could be either Redis or Fuseki itself. So actually, I don't know if you had the Java command set up properly within there, but also if you're doing like the Linux subsystem, that would probably fail spectacularly. Well, he already invested in the hardware, and you know. Okay, cool. Yeah, that's promising. But yeah, I don't know. Yeah, you don't. Well, the other thing is that you can just use Docker now. I'm not going to go over the process in this.
Don't do research computing. Yeah.
Okay, so we've installed Whyis, lots of sub packages, lots of things that can go wrong, but it didn't, thankfully. Okay, so what did we do? Oh, right. The knowledge graph application in Whyis, I've been calling them KG apps. So like web apps, but knowledge graphs. So KG apps. So I'm going to make a directory called demo KG app. And then from here, literally all we need to do to start Whyis is run Whyis. It would, yeah. Yeah. Right, yeah. There we go. Just compiling everything. So what it's doing, let me run through exactly what it's doing here, because I know you guys are fascinated by this. So what it's doing, so there's, I'll explain kind of the configuration system, maybe if we have time. But basically there's the KG app configuration, and then there's the system configuration. System configuration is for deployments on production. There's this idea of an embedded configuration, which the idea is that it's what it does is it has some defaults in place that lets you run everything locally. So you can take the same KG app, run it on your laptop, and then also be able to deploy it to a server, and it won't, everything will work the same. And because you don't have a system config set up on your laptop, you won't be using those things. It will use the kind of the built-in stuff. Whereas when you deploy it to production, it will use the system.conf that you created. It starts Fuseki on a random port. So you can actually have multiples of these running at once. It will then build out the endpoints in Fuseki for you. It starts a Redis instance, which is used as a bulletin board for the inference agent system. And then it starts Celery, which actually runs the inference agents. So that's the infrastructure in Python that goes to the bulletin board and actually pulls tasks down and so forth. And so every, all the agents are actually, they're not direct Celery tasks, for those of you who know how Celery works, but it is basically all of the steps of the inference agent process are different tasks in Celery so that it's kind of processed through that. It's also set up so that you can monitor kind of tasks because they are marked with the agent type and the URI of the Nano publication so it's looking at and all that sort of stuff. So that's it. Redis is an embedded database, and it's used to it is a basically serves as the bulletin board for tasks for Celery, and Celery is what actually runs the inference agent system. Yeah, exactly. Yes, that is something you can set up if you like. Right, yeah, yeah. So what would happen? Here, let me show you what it's actually created. New window. Here, I'll hide all this other junk. Not yet. Or if they did, it hasn't reached my computer.
Which Adam?
Could be. But I mean, it's an open source project, right? So, okay, so demo KG app. So what we have here, actually, can I make this? No, I can't make it bigger. Right, so Whyis.conf contains like I said, the kind of the functional aspects of the knowledge graph. So things like what the LOD prefix is, or kind of where to look for the vocab file, which just defines the views, and the site name description, what inference agents to run, what link data importers to use, and so forth and so on. Yeah, yes, it is. The other thing that you come with is, so right now, at the moment, because there's a system running, there's this embedded.conf file. And this is actually written out as JSON. Actually, it's a pain in the butt to read, sorry. But what there is there's basically, when you install it on a system, there's a system.conf file that sits right next to the Whyis file in the same directory. And what that does is that configures, that tells Whyis where to look for Fuseki, where to look for Redis, where to look for Celery, and all that sort of stuff. And it also is set up to be, basically, it's meant to be configured on a server. There's also, and actually, I think I've got, right. So in here is the system.conf file, which has some specific variables in here that get replaced. So when you actually install it on a server, this gets written through and so forth and so on. But basically, there's a script that goes through and installs all this stuff into the server, sets up a Fuseki.service into your system.d, sets up Celery and Celery beat service to do the same, and installs Redis. And if you look at, yes, they're like a limited Python file, but yeah. Yes, the ones that have to, that's how, that's actually a Flask thing. So if you have Flask using if you're writing a Flask configuration file, you use this to distinguish between variable entries that are not actually configuration values and just regular variables. Oh yeah, yeah, yeah. In fact, here's one. Yeah. And so the so setup actually goes through the process of, so you just run this on your server when you're ready to deploy. It will go through and install Redis. It'll install Apache and the Python that you need. It will set up the directories you want, and configure Celery as needed. It will it'll pass through these files and add configurations to them and basically restart all the services. So it's basically full-fledged. You can go from, like, I can take this KG app that I just generated, copy it over to a server, run it, and get the same experience that I had on my laptop, except it's production. No, no, it's it's the rest of the stuff that used to be in that. So the old config.py that used to be in Whyis was a combination. It had stuff from Whyis.conf and system.conf put together. And so this is the idea with the splitting it out makes it easier to deploy and embed. Yes. Yes. I'm sure, yeah. Well, some of this is I'm trying to get trying to get everyone up to speed on kind of a lot of this stuff. So when we start off with a knowledge graph, we have just a basic page that starts up. And as I said before, there's a, when we look in whyis.conf, so this is the LOD prefix. So when we go here, we're actually serving up this page, that URI. So even this page has a URI associated with it.
So when you launched it, there was a couple different URLs that were provided, which was the last one.
Right. Which ones? These guys? Socket ones? That's not going to work. No, that's the only one. Oh, wait, these guys. Yeah, so. Oops. So yeah, so if you, basically, so you can actually go, once you know what it's telling you this so that you can access it directly if you need to. Okay. So you do still have to register in order to make changes in the graph. You can do this through the command line as well, but I want to show the user interface for joining McCusker. IPI.edu, no, edu. Okay. So register, and then what you have is sort of another prompt to add knowledge, because it's an empty knowledge graph right now. So we can start by uploading a bit of knowledge. And what I'm going to add actually is going to be some very simple knowledge that we have, which is in the in Whyis we have this. There we go. There we are, base.trig. So this is basically SCOS and DC terms and RDF and OWL, RDFS. All the labels for those namespaces are all in this base.trig. It's a really valuable thing to start with. And it's got them all broken out into separate named graphs, so you don't have to do that. And so that's basically added things. And oh, look, now we have instances of stuff. And so if we look at, for instance, so this is a gallery or album, depending on how you want to think about it, of kind of the top 6 types in the graph. And as we add new stuff to the graph, we'll see that change. Because this one is OWL classes, this one is RDFS classes. And so the other thing is that when we look at an actual a class view, it automatically shows all the instances of that view or of that class. Oh, so this is fun. So we have, oh, this isn't going to show. Yeah, that's all of them. But if we look at RDFS class, I think we have more than 20 in here. And so what we do is we have no, actually, yep, we have an infinite scroll. So it only shows a little bit at a time, and every time you bounce off the bottom, it will show a little bit more. I think it's 24 at a time. So of course I'm showing it 5 wide because it's the only thing that so this is a fun, I love Flex. It's so cool to be able to do that. I've been waiting years to be able to do that. And oops. Yes, yeah. In fact, when I load the data that we're going to use, I think that will actually work. One thing I'm going to do is I'm also going to add I'm going to add SIO to this because we use SIO for a couple of things in the example data. Actually, SIO. Labels. Oh, that's an old one. Oh well, that's probably fine. Format, RDFXML. So we can keep adding, you can just add turtle from anywhere using that menu afterwards. And actually now we should get even more, we should have even more OWL classes because we just added SIO to this. So yeah, all sorts of stuff in here now. I'm just double checking that. Yeah, okay, cool. So the other thing we can do, so as I'd mentioned before, you can upload data into Whyis for processing or just for publication. This is a pretty cool thing that we added as part of one of our projects. But this is actually so you'll see this is actually a view where the URI is dcat data set and the view is new. So it's actually, if you were to go to any class, you would get something that allows you to create a new instance of that class. The one that's in there right now, the default one isn't that great, but the idea is that when you have an action like that you're trying to do, those would always be done through a specific view. So view, new, and edit are all kind of standard web-facing views that we have in Whyis that you should use. Other ones include explore and gallery and other stuff like that. So like the gallery view will show all the instances of it by itself instead of having it be in the main page. If we had a DOI for this data set, I could just plug it in and it would load that through. I'm just going to select some files though. Data, Whyis demo data. So this is a data file of, this is the 2010 census. Hold on, pull that up. So, yep. So I modified it a little bit to make it a bit more tidy because the official one is really kind of gross. So county, state, census. It's still not tidy, I know. The part of it that I'm going to use is tidy. I'm just using the census value. I'm not going to use the other stuff. Yeah, I know. I know. You can add a preview image for this. Actually, I'm going to try to find one real quick that here. This is the logo for my race, but whatever. So we'll pretend that's has something to do with the census. So it will upload census 2010. I'm going to make myself the, so one thing we expect is that we use ORCID identifiers as contact points for these. So I'm going to grab my ORCID. We don't have it mapped in yet, so let's see here. And then there's, you can look up contributors, add those, set a publication and modified date. I'm going to do today for both of them. And so it'll show you a summary of it and then you submit. And then in the end, that's what you get. So you have a summary of that data set. And this is the view equals view. And if you go to view equals, what's going on here? Close, view equals describe. You actually get you get some metadata for it, and it's all linked data. So if you actually negotiate for RDF from this URI, or even actually because of the way this works, so this is kind of an escaped URI, but I can actually take this and what is going on with this?
Well, you've got a DOI for it. The data site DOI.
You could do that, yeah. But and there are other ways of making data sets where you actually set the URIs explicitly. Let's see here. So the other thing that
I guess the question is, where did it put this metadata?
it put it into so this. Let me make this a little bit bigger. So there's this URI here that was used.
Yeah.
And so that actually is, oh wait, sorry. That actually pulls through to 0.1. So that passes through to localhost, which I don't seem to have mapped properly at the moment, to display that same data set. Although,
well, I guess the question is, where is it relative to what you've been constructing so far, or is that?
this is its own thing, right? So because of the original use case for it, auto-generated URI using UUIDs. So that's what this is here.
Okay. This is just, oh, by the way, here's what.
Right, exactly, yeah. But the cool thing is that, so now we have this data set as well. Although, what's going on? Suddenly, oh, right, there we go. So this is the actual file that we downloaded before, or we uploaded. And actually, if I strip this off the end, it will serve up the file. Yeah, so it's loading it in numbers, yay. But basically, so yeah, it serves up the actual file when you access it without as a default view. So you can actually use the URIs as just to serve the file itself. So
that becomes really interesting.
right, exactly. Yeah, so that's so if I go here, if I place this in here, so partly because this is, so what we're looking at is basically the same, this goes to the same place. U equals new. Wait, what did I do? Oh, view equals, sorry, view equals view. So if I don't have u equals u on it, it'll just serve up the file again. But so yeah, so that's what we do is when we're just generating URIs, for the most part, we use this about shortcut so that we can reference anything in the graph. So that's kind of the safest way to reference things. But the about way. But the LOD prefix method makes it basically lets you serve up linked data for the entities that you are directly responsible for in the graph and for the things that you really want to show that way. And so they're really good entry points for that. Right, so the other cool thing though is that I can do SDD census.
Spell it without the
CENSUS.
Why, that's not when you answered it.
I think I corrected it in time. Because this only comes from that.
Okay.
So the other thing we can do is, rather than just using that form, we can actually upload individual files as well. So what I'm going to do that real quick with the semantic data dictionary for this, which is a Excel file. And so you notice this extracted. So it's figured out, so added when it was created, extracted the content type, and this file ID is actually the reference into a file repository for use internally. It's just easiest to just put it in the knowledge graph. And it also marked me as the contributor again. So it knows that I created it's basically gleaned as much provenance off of the transaction automatically as possible. I mean, I only give it two pieces of information. So then you just, so you'll notice that I just made up this STD census URI, and there wasn't really anything there. I was just saying, there's this thing, I don't know anything about it. Here's what I know, which is nothing. Now it knows a bit more about it because I did that upload. I could have just as easily done about URI equals and then the URL to where it's going. and that would give us the same thing. One thing, so it also gave types. So it actually pulled out the type from the content type. These URIs are actually related to the the media types from that are used everywhere. And so it actually has a URI for each of those. The other cool thing. Oh wait, did I?
This would have been very useful when you built it. We essentially had to do this.
Right. Yeah. Oh wait, I need to add one.
You go across with CCAN.
Yeah. No, data. Where is it? So there's another ontology that I wanted to add. So the semantic data dictionary ontology as where is it? SCD ontology. This has some information about DCAT and semantic data dictionaries and other things. So this is valuable to bring in because before we didn't know anything about semantic data dictionaries. Now we've added a bit more vocabulary, and what we can do is we can add a type of semantic data dictionary, which wasn't there before. Submit, adds it to the type list. Doesn't. What just happened? Did I crash something?
Smoke up.
Yeah. Let's try that again. Okay, well. No, it's still broken. What did I do?
So describe what you were trying to do was kind of by that semantic.
Oh, yeah. Why is it actually pulling? Oh, it's your STD view. Your STD view is broken. Okay, let's not worry about that. It's your fault.
Way to defer.
Yeah, exactly. Okay, so I just wanted to upload it and set the type. Apparently that caused a bit of trouble. Yeah, so view equals view. So what I can do from here, from the original data set. So now that I've added that as a piece, so what I'm going to do is I'm going to say, I'm going to add a few bits of information to this. And what it's going to do is it's going to trigger that, I'm going to link the SUD to that data set so that it can process it and add it as a graph. So I'm going to add this as an attribute, URI space, which is from void, local, and then 2010. I'm going to add to this. I'm going to move myself out of the way. Oh, that's annoying. Okay, so I'm going to right, I need to add an attribute here of delimiter. Because it knows that it's a CSV, but it doesn't, like CSV doesn't mean anything necessarily. You don't know what the delimiter is for that automatically. So I'm going to add that as a delimiter for this file. I'm going to then add a link conforms So yeah, there we go. Conforms to, and then the census file, which we already have in there. So that adds that as a link. And what should be happening now? So it's doing that stuff. And actually, if I go into run logs, log, it's actually transforming the data into RDF already. And
The conversion.
yep, and something break. Right, hold on. Something went wrong. Did it break?
So conceptually, what you've done is
Shoot.
in the STD, you've got
No, that was right.
find what you've got that STD building, find that to this log, the raw data, which is up there.
Mhm. Yeah.
That manifests the data is the graph. What is that? Is that stand by itself? Is that balance graph or is that?
Okay.
Set that you operate? Where is that?
Sorry,
Where is the graph that you created? Is that included? Sorry.
right, yeah.
When it linked to the data set itself?
So the data set itself is now
This is essentially a view.
right. So one thing that happens in here, yeah. So this is but basically it's not just a view, it's actually been added to the knowledge graph itself.
Well, yeah, I'm saying that it's added to the knowledge graph itself.
Yes.
And my question was where, and what I'm saying, asking is where, essentially, where you added the data origination.
No, well, so it's a knowledge graph, right? There's no where in a knowledge graph. There's subject, predicate, object graph. And so everything. Well, so first off, there's
The URI for the data set.
yeah. Right. Well, so first off, it's more than one graph, but also the the actual settle actually yeah the settle script doesn't show quite everything. There's a couple of links that we could probably put into this that would make that easier to navigate. But essentially in the nanopublication trace, all the nanopublications that are output from the semantic ETL script are linked to the settle script, which has a link to the STD and this file in it. And so let's see if I look at this. This might actually have it. This is more direct usage of it. Right. So this is actually from the settle script itself, this used of, which is kind of silly. But yeah, we should probably have a bit more in there about that. But what's happening is that there's a series of nanopublications that are generated, one for each row in the data file, that are traceable at the nanopublication level back to this.
Yeah, so
through the settle script.
Let's go ahead and simpler. But you're
right.
Managing.
Right, yes.
So that's a lot more complex than my, I'm kind of looking for this.
Right.
UII,
Mhm.
that is.
Yeah.
Okay. So, it's the different version.
Mhm.
Those are the graph.
Right.
My graph. Stuff that in, that's a company. So
Right.
that's it, sort of like that URI that's got a root of this, which child graph.
There is no child graph. It's just another it's another subgraph of the knowledge graph.
But it's. That's it.
Yeah, it was generated. This is derived from that.
Right. Yeah, I understand what you're saying.
Yeah.
Probably that.
I should wrap it up. Yeah. So I'm going to show really quickly so we use Sparkle or we use the Yas GUI interface to do stuff. And then there's also there's this visualization piece that is pretty cool. And so right, so this will show all the instances in there. Oops, although this unfortunately not all classes have labels in this development, but it's
So we put this like kind of into like.
yeah. Yeah. Oh, wait, it's still, okay, so it's actually run this. So we can do, no. No, that's not the right one. What did I end up putting in here? And yes, I promise I'm gonna wrap up very soon. So prefixes. So these are the counties from the data set. And this is not actually going to do anything. So distinct X, and this will actually this won't show anything yet. Table wasn't showing that yet. So what it's doing is it's processing through all the nano publications right now and basically saying, hey, is there anything that we could further determine from each of these new fragments? There's one reason why it's all kind of broken up into the small pieces to make it more digestible. And so it's kind of working its way through that right now. And so the population, oh, right, that isn't there. Why didn't that show up anywhere?
Live demo.
Live demo, gotta love it. So population XA. So right, so is that Okay, so it's basically has all these population objects in there, and actually, I can show you. Show you one. We'll see if it actually is right. But the other thing is that since this is, I mean, I could have just gone to there for my localhost was set up right on my computer. But right now it's kind of chugging through all this stuff, so it's a bit. There we go. Instance of population. And it doesn't look like it was connected to anything, but it did take the time interval of uh, January 1st, 2020, and or 2010, and the count. Yeah, it lost the link to the yeah. Here, I want to show you the actual data because I kind of want to prove that I did get it to convert properly at this point. Data, Whyis demo data. Okay, so yeah, so this is the data that was actually being converted. Here we have Medina County, Ohio, part of. Yeah. Right. Yeah, and so each gets its own name graph. And then and so here it's got the link to the different things, and then all right. Insertion hub info has the link of this was associated with a particular row in the data. And then this is a CSV row as a row number, so you can trace it back to a specific row in the file. And then this was derived from. Oh, that's all the same. Hold on a second. Hub info, assertion and provenance. Right, provenance isn't there. Okay, so yeah, so I probably should expand on what's actually available in there a little bit. But in terms of linking it back to the original data set. But this is the idea is that it's it's still more or less available in there, and but it's actually doing that conversion kind of systematically, has it back in as more pieces of the graph, and those can be processed by other agents as well.
So, I'll ask you.
Right.
Next week, talk about it comes down to this thing called the floating solar, the co-host floating solar explorer, which is a very interesting app. Several of the GIS things. Kind of put in the boundaries on the data
Mhm. Yeah.
At its core, it's about data.
Mhm. Right.
So the real challenge with these, it's the kind of thing where you conceptualize it really, like, version of lives. Now.